Thank you very much. Thank to all the speakers and the attendees for your attention and patience. I hope that you have enjoyed. And now we will start with the Q&A session. So the first question is to Paul. Your heavy automation sounds good for Agile. What real benefits do your customers see?
It's a good question, Jelena, and thank you. It's been a pleasure to join you today. Yeah, the benefits to ourselves are quite large, of course, but it's the benefits to our customers that are most important, and certainly making the difference between ourselves and perhaps other providers of analog IP. When we were forming Agile Analog, we did a lot of research, and we were shocked to see that in our own studies, 85% of the problems, as I've said, in SoC design came from the mixed signal side, came from the analog IP. And in fact, there's some other studies have shown that that's more like 95%. So what we've tried to do is to make sure that there are three key aspects. One is to make sure that the quality of the IP that people receive, certainly from us, is as high as possible. And that's a major part of the automation, making sure regressions and everything else are extracted from the one particular database. So quality is critical. And if we're going to increase the number of analog IPs being used by general companies, not necessarily those with expert analog designers, then that risk needs to go down hugely. Second thing is the flexibility. If you want to use a piece of IP, it needs to be specific to your particular requirements. And again, this is what we did as I described. We take a customer specification and design specifically from standard blocks that are architected very well and verified to their particular requirements. So that flexibility not only goes into the design, but also in providing that IP throughout their design process. So if they need changes early on, or very late on in the process of integrating our IP, they can come to us and we can make those changes. So that is pretty critical. Really flexibility, no compromises, you get IP that is to your specification, and quality. And because it is automated, we can also do it very, very quickly. So those are the benefits our customers see. We have benefits as well, of course.
Sounds great.
Thank you.
Sounds great. Thank you very much on your answer. The next question was for Markus and Patrick. It is Asic Design a new product? How many tape outs do you have?
Oh, yeah. Let me take this. No, Asic Designer is indeed around for quite a while. It is the consolidation of two product lines that have kind of innovated this whole industry of custom design processors. And then we merged this technology within Synopsys after having acquired both companies, one being Target Compiler and the other one being Coware and Lisatech. By today, we have more than 300 tape outs that we are counting, and we're not counting. So our customers might not tell us about each and every tape out, but it's very well-proven technology. So it's definitely, it's not a new product. It's constantly evolving for sure. It's evolving with the example models that we talked about, but the technology as such is very well proven.
Understood. Thank you very much on the answer. Hanan, is in-life analytics limited to the use cases shown in the talk?
Yeah, thank you, Jelena. So yeah, we did highlight a few example use cases around automotive, self-autonomous autonomous vehicles, connected vehicles, 5G, and etc. But absolutely not. The world is out there for applications and customers to discover and to use for whatever target market they're going after. So the tools, the IP and the tools provide giving the building blocks to allow you to collect data from within the device and then process it and apply it to your own specific domain and use case. So, yep.
Okay, thank you on your answer. Next question is for Scott. What is the strong point in Chips&Media video IP compared with other video IP providers?
Okay, the first one is our IP is frame-based codec. Therefore, Chips&Media video IP has a simple call sequence by setting host registers from host to CPU, and it consumes the minimum host to CPU load. And the second one is because Chips&Media video IP has a small CPU, it is flexible to accept the new feature requests and to cover some unexpected issues in firmware side. And lastly, multi-instance support to cover the multiple streams with a single video IP by context switching.
Okay, thank you very much. Siddharth, how can we partition the analog blocks for better macro library creation?
Yeah, so there is no single way of partitioning the analog blocks, right? Because there are various varieties of blocks. You can just not put one formula to partition them. But it requires some expertise in that particular domain. So how we partition typically is for any given particular analog block, we work with the domain experts, try to understand what are the real building blocks for that particular analog block, and then partition them into separate macros. And this is not a one-time exercise, right? Because sometimes you might figure out that after designing the macro, you actually wanted to partition it further to make it more reusable. And that's a continuous improvement which we keep doing on that.
Okay, understood. Thank you. Thank you for Dušan. Can vendor-proof accelerators and third-party checkers be included in this reuse model?
Yes, absolutely. Generally, it depends on what kind of checker and proof accelerator it is. Anything module-like can be included in this flow. You just use the same approach. You bind it to the RTL. You will lose some abilities, such as for example, third-party checkers don't use the same naming convention as you. So you might have to just see what they contain inside and whether they add some additional assumptions that you don't want. And since this flow will miss them, and if you need them disabled or modified or something, yes. And you mentioned proof accelerators, right? Yes, if you're using formal, if you want to use them on simulation level, I don't think so.
Okay, thank you very much. Then second round of questions for Paul. What do you have on your roadmap as your next architectures for general release? The question was for Paul.
Hello, Jelena. Yeah, sorry, I was on mute there.
Of course.
Yeah, good question. Yeah, we have, as you see, quite a wide portfolio of products at the moment. There are a lot that we're doing for customers that are not on there as yet as general release products. But we have a lot of additional resources going in this year. So we're looking at those roadmap developments that we need to put in place over the next 12 to 18 months. Sigma Delta ADCs are an example, switch mode power supplies in certain areas, and there are a host of others. So we're very willing and able to enhance that and also to talk to customers. So we need to be directed by our customers. They're helping us at the moment. So if you have a requirement that's not in that list, please come and see us. Thank you.
Okay, thank you. Markus and Patrick, another question. Are your RISC-V models ready to use as is?
Yes, I'll take that one. Yes, the RISC-V models, they can be used as is from they come in NML source code, so they are ready to deploy it by customers. Customers may want to consider to add caches or a bus interface to it. But the main purpose of the models is using as a starting point and creating their own ISA extensions to the examples. But yes, they are ready to be used as is.
Thank you. Next question for Hanan. What hardware platforms can embedded SDK run on?
Right. So as I mentioned in the talk, embedded SDKs is a series of software libraries that you compile into your software. So we deliver it as just C code, source level C code, MISRA compliant, and so people are targeting it for any and all CPU cores, ISA, so whether it's RISC-V that was mentioned earlier, ARM of course is quite popular, ARC and others. The other thing I was going to say about that was, yes, in terms of operating system, it's just simple simple sort of low-level libraries that can be integrated either into a bare metal environment in conjunction with some RTOS or with embedded Linux, just to name a few options. So there's no built-in limitation to what hardware platform it can run on. Thank you.
Thank you. Next question for Scott. Does Chips&Media have the schedule to support AV1 and VVC video standards in Wave 6 series?
Thanks for the question. For AV1, Wave 6 to 7 AV1 multi-standard encoder will be available by second quarter this year. Mm-hmm. And Wave 637 AV1 multi-standard codec means encoder and decoder version will be available by third quarter of this year. And Wave 677 AV1 multi-standard dual-core codec version will be available by end of this year. For VVC, we have a plan to be available next year.
Thank you. Next question is for Dušan. How often do you use this DV technique, and what are the benefits for the client?
Well, I use it as often as I can, I would say. That's not always my decision since, well, ELSYS is a service company, and sometimes we just have a client who says, okay, we want this verified this way, and we already have some kind of a flow, and we want it done this way. So in that case, we try to raise awareness of this flow or something like that. As for the company, we have a developed training for formal verification, internal training, which kind of mentions this techniques. And yeah, the second question was the benefits. Well, the benefits are mostly discussed during the presentation. I can maybe give some other examples from an actual project. We were verifying this state machine, which was in charge of controlling some other parts of logic, which were controlling some voltages and currents. And it was in charge of this powering up and powering down sequence, the ordering, the reaction to some errors, and so on. So the FSM was verified on IP level, and then this model was reused in SoC level again do the formal verification. And on top level, we just handed that over to the people doing simulation, and they kind of benefited from it by making sure that their tests exercise the biasing enough. And yeah.
Okay, thank you, Dušan.
Thank
so
you.
the next question is, I assume for Paul, how is your deliverable different from an off-the-shelf IP provider?
All right, another excellent question. To a certain extent, it depends on the nature of the off-the-shelf IP. If it's sort of standards-based IP, such as Scott was describing, for example, or SERDES or PCIe, then generally you take it as is. It is a big piece of IP. It's meant for use within a certain envelope of applications. However, if it's the more usual lower level analog IP, which now increasing numbers of designs need, you know, the LDOs, ADCs, whatever, then these things are things that you really do need specified to your requirements. So you can take those off the shelf, but if you're using something that's been designed for a generic use or for somebody else previously, it's not exactly as your design requires. So we give the customer now the ability to have that exact requirement to their specification, but with the quality that means that it reduces the fear, the risk that they've seen previously. You know, we've got to drive down that issue level with analog design generally, if it's going to be increased, if the number of analog designs in standard SoCs is going to go up. Hope that answers the question. Thank you.
Thank you. Another question is for Markus and Patrick. If I extend a RISC-V model with SDKs instructions, is it still binary compatible with the RISC-V ASI?
Yeah, that's another good question. So the answer is yes. So the SDX ASIP example model has been designed with the SDX template ISA instructions as part of the custom space of the RISC-V ISA specification. That means that when you have C code and you compile it with open source GCC or GNU compiler, then that code that you compile and run on the TRV ASIP models, it will run. It will execute because, yeah, that code compiled with the GCC compiler will not use that extension instructions. So yes, it is still compatible with the ISA and GNU compiler.
Thank you. Another question is for Hanan. Can I use in-life analytics and embedded analytics IP in an FPGA-based design? The other part of the same question, what about specific technology nodes?
Thank you, Jelena. Yes, so I mentioned earlier that the embedded analytics IP portfolio has about 30 different IP modules covering different functionality from control and monitoring and trace collection, amongst others. All of that IP is delivered as synthesizable Verilog RTL. So it can be targeted to obviously an ASIC, which is the kind of the interesting part, but people are using it on FPGAs, whether as prototyping or in some cases, you know, a lot of people are building FPGA-based products. Not everybody goes tape out in that regard. People use our IP in emulation environments as well, so they get to experience the IP and the software interactions early on in the design cycle. So to answer the first part of the question, put it anything that will synthesize Verilog RTL, you know, can take that. To the second part of the question, again, because this is just synthesizable Verilog, we're not tied to any particular technology node. So synthesize away and may the force be with you, as they say.
Correct. Thank you. And to Scott, another question, maybe the tricky one, but it is for you written here. Please share the information which customers are using Chips&Media video IPs, if possible. So Scott, please.
Okay. Chips&Media has a broad range of customers. Our key customers are developing set-top box, mobile phone, and automotive and AI-based products, and etc. And our products are silicon proven in the market and widely used in the commercial electronic product. We are working with a well-known company now, and we are trying to get another opportunity with the well-known company as in global. Thank you.
Okay, thank you very much. Just to see. Okay, another question was, are your IPs tied to any specific foundry or process nodes? I assume it is for phone.
Okay, no.
No.
Our aim is to provide, I think the term is foundry agnostic IP, because we design from our architectures specifically for the design, and we do that very quickly. We can also redesign if a PDK changes to hit that new PDK, move the design to a new process, or in fact move it between foundries. So no, not specifically to a particular foundry, and we have capabilities that will move designs between bulk processes, for example, to FinFET processes, and we can also design for BCD. So we have a very wide range of processes that our IP is applicable to. Thank you.
Okay, thank you. The next question is, what is your licensing model?
Is this to me again?
I think so. It's not clearly indicated, but I assume it is connected. So yes.
Okay. Well, the other guys can come in with their answers. But yeah, as one of the slides I think showed, we're very flexible in our licensing model. So if royalties are interesting because you want to defer cost, then we're happy to do that as risk sharing. Many customers do not want to pay a royalty, and we're more than happy with that, and we'll just do a standard licensing. And they can license the IP to go on one particular design or multiple designs, one design on different processes, or multiple designs on different processes. So as you can see, it depends on what the customer wants. But we have done and are doing virtually all of those. Very flexible. Thank you.
Okay, thank you very much. The next question is, are you providing digital supports too? Again, it is not indicated. So the rest of the questions are not clearly indicated to which speaker are those. So please, if you recognize yourself in some question, feel free to answer it.
Well, again, I'll let the other guys speak then. We are an analog IP provider, but our IPs must sit in SoCs, which have a major, generally digital component. So we help customers with that integration, looking at noise issues and the like. So yeah, we do deal with that. We don't design digital, but we help people integrate the analog. Right, over to the rest of the guys.
Okay. Someone else on this question?
Well, maybe I'll take the opportunity to go back to the previous question in terms of licensing models. So I think in a similar approach, I think, to what Paul had described, there's a great deal of flexibility in terms of upfront, fully upfront, single-use, multi-use licensing, with royalty, without royalty. It's all up for discussion with the interested customer. I think for the second question, I think it probably was addressed initially to Paul. I think it came during his presentation earlier on. So obviously our IP is fully digital. So I think there's not much really to add on that at the moment. Thank you.
Okay, thank you. The next question is pretty assumable that it is for Markus and Patrick, and the question is how this tool supports RISC-V. The other part of a question is not it competing with your own ARC processors?
That's Markus. Let me take this. So this is a good question. But if you recall the very first slide that I had in my presentation, it was showing the portfolio. With our ARC product line, we have a very well-established and very successful product line of processor IP, which comes with all the value of verified and certified IP. And that is, of course, a key asset for someone who finds this to be an exact fit. With Asic Designer, we enable our customers to build their own specialized processors whenever they do not find the right IP. So RISC-V for us is therefore not the end. RISC-V, the instruction set definition there is a good starting point for people to start to design their own processors. And that's what our tool is meant to focus on. If you're just looking for RISC-V plain, some open source, you might find other solutions to be equally suited. But if you want to do some differentiation, you want to specialize through the concept of SDKs as presented, or take it to even more specialized architectures, then our tool comes in. Our tool is therefore a design tool. It's not IP. And RISC-V just happens to be an ISA that many people know about, so it becomes a good starting point, and that's why it is being addressed. And having a good starting point, a high-quality starting point, of course, then helps also to come to a high-quality end result. And that also addresses this other question. Our licensing model is really it's an EDA design tool, so it's really based on a time-based license. So and you own the design. It's your design, you own it, and there are no royalties or license fees attached to the design itself.
Thank you very much. The next question is for Paul. Is this tool available for evaluation and non-commercial use?
Okay. I mentioned this very briefly. We're an IP company. We've developed, obviously, as I described, a methodology for quickly developing specific analog IP, and that's where our focus is. This is a question we're asked more and more, particularly by our customers who've seen the benefits. So as I alluded to, we are looking at making certain aspects of the tool available. It won't be for some time there, but we have an advanced development partner program to enable people, or will enable people to play with aspects of the tool. But really, we're an IP provider, and our tool is not commercially available, certainly at the moment. Thank you.
Okay, thank you very much. Currently, we have less than 1 minute left for Q&A session. So just if this automatically stops, I would like to use this opportunity to thank you all attendees and speakers for being a part of Semiconductor 360 Live, the first and I hope very successful event in the future. I would use this opportunity to call you to stay on the exhibition and listen to other sessions and actually enjoy and make the most benefit for you and your company out of this event. By that being said, I would also give it a try to provide with one more answer, but if it's cut by the system, you know what happens. So another question is this RISC-V going to replace your Arc Legacy CPUs? Markus and Patrick, I assume.
I think that was the previous question, Jelena, already. So that's the one I tried to address
Another
before.
one would be, what is IP and course? Could you elaborate in easy language? Someone asked.
Well, I can try. So course is we typically refer to processors as the component, while IP, it's a subset of IP. We often refer to it as semiconductor IP, which are building blocks which you're using for as an integrate or as a part you design into your SoC design. So that's one very simplistic way of looking at it is that with IP you take advantage of the components that have been built once and are needed by many, and it's intellectual property that someone else adds to your design, so you can focus on the differentiation in your design. And cores, that's what we refer to pretty much to a processor that is then, which is also a piece of IP. That's, so that would be my answer.
Very good.
Okay.
Thank you very much. Thank you all for your participation and being a part of Semiconductor. Okay.
Thank you.
Thank you, Jelena.
Bye-bye. Thank you, Jelena.
Bye-bye.
Thanks. Bye. Bye-bye.